Hey everyone! In this video, we're going to recap the question about Scooby-Doo's workout plan. So Scooby-Doo believes that people perform better in the barbell curl on average if they are encouraged by a coach. He recruited 29 subjects to participate in an experiment and randomly assigned them into two groups. Scooby-Doo gave one group verbal encouragement during the exercise and was quiet during the exercise for the other group. He recorded the total number of barbell curls each subject was able to complete before setting the bar down. Now, part A exists to explain the purpose of random assignment. So random assignment is utilized to create two groups that are roughly the same in their ability to do barbell curls. This allows the researcher to use the results of this experiment to determine cause and effect conclusions if the difference between those who receive encouragement while curling barbells and those who do not receive encouragement is statistically significant. So basically, because this is an experiment for us, we're doing this test, we have to make sure it's random, right? It's one of the biggest conditions we go through is making sure we have randomness in there. In this case, we really can't get random selection. It's hard to select from just a pool of everybody because not everybody has the same ability to do barbell curls. So we do need to get a group that are willing to do barbell curls, but how we can make this random is the assignment of which group they're going to be in. Everybody's participating in completing barbell curls, but we're trying to figure out if they'll do better with encouragement. So that being said, the random assignment is what makes this okay. Since it's random, we can utilize the results we get to determine cause and effect. Now, the big thing about this problem, though, is we would not receive full credit if we don't have specific context. Notice how in my response, I specifically mentioned those receiving encouragement while doing the barbell curls and those who do not. So in any question you answer like this, you have to tie context back into the problem. Remember, basically, every question needs context in there. One way you can check if your response is appropriate is if you've read your answer and you could just put your answer on another question in different context and it would still be okay and make sense, then that's not okay as far as getting full credit would be concerned. Every question has to have context in that answer. Otherwise, they're going to dock you points. So make sure you have some kind of mention of curling the barbells here with encouragement and not encouragement. Now, you could have definitely said mine less wordy, but basically the big idea is that random assignment can create a reasonable cause and effect, or that you can make conclusions about the population from where these subjects come from, and context about barbell curls. Now, part B is asking us to compare these distributions. So we have our two box plots given. So this is a stocks question, right? We've got to talk about the shape, the outliers, the center, and the spread. And since the word compare is in there, we need comparison words. Greater than, less than, equal to, about the same. Like you're comparing the two different situations of encouragement and not being encouraged. So these distributions of the number of barbell curls is slightly skewed to the right in both groups, with a higher skew for those who were not encouraged. Those who were encouraged had a greater median and a greater variability in the number of barbell curls. Neither distribution had any outliers. So notice right in the beginning, I talk about what the distributions represent, the number of barbell curls for both. That's enough to say that there's my context, okay? Slightly skewed to the right in both cases here. You can see that because the medians are to the left, so there's more on the right side. Remember about like thinking about that slope situation if you're going down the ski slopes, right? So we have the shape there. We mentioned that neither have any outliers, so there's our O. Centers talk about the medians and where they stand, so we can see how we have a greater median for encouraged based on this line here. And variability has a bigger spread. Okay, so we're definitely making sure we talk about all of those things, and we had context tying it all together. One thing you can never talk about, though, from a box plot is the peaks, right? We can't tell if it's bimodal, unimodal. We don't have that. So we never want to mention anything like that from this picture because we can't tell. We don't have that definitive proof. We could say it's roughly symmetric, right? Because even though we said slightly skewed to the right, we could probably get away with a rough symmetric, but we really can't say approximately normal here yet because we have no evidence of that, right? So we're gonna avoid any kind of peak talk or approximately normal here. Now, when we get to part C, state the hypothesis Scooby-Doo should use to test his belief about receiving encouragement during exercise. Make sure to define any parameters. Basically, any kind of question about a hypothesis, they need you to define your parameters. So this one was nice and they mentioned to do so, but we've been doing it all year. Make sure you have that context in there, even if you're not told to, right? You have to tell us what mu of E and mu of N would be. And notice we're using mu because this is quantitative data. So mu is used for that true mean anytime we're doing something quantitative. So in this case, our null hypothesis would be that mu of E is equal to mu of N, and our alternative is mu of E is greater than mu of N. So mu of E is the true number of barbell curls people can do with encouragement, and mu of N is the true number of barbell curls people can do without encouragement. So remember, we knew that it was greater than in this case because of the context in the problem. Notice when I go back, Scooby-Doo believes that people perform better in the barbell curl on average if they're encouraged by a coach. So because of that first line, that tells me our alternative is encouragement is greater than with no encouragement. Now, if it said there was a difference or they're not equal to, like that's when we would use not equal to. And depending on the way the wording of the problem is, you could end up with it being less than. But this particular problem had us being greater than. And this is all set up as a 2-sample t-test, okay? Because you're breaking up those two groups into independent groups, the ones being encouraged and the ones not being encouraged. And they have no bearing on each other. But if Scooby-Doo did this setup a little bit differently, this could have been a matched t-test, right? So if we took that matched pair, he could have taken all 29 subjects and had them perform barbell curls both ways, right? He could have recorded with encouragement and without encouragement. And what would have been random in that case is the order in which they completed the barbell curls. So they would have maybe flipped a coin, heads and tails, and assigned encouragement and not encouragement for each person. And that would have been their random assignment, but had everybody do it. Okay? If he set it up that way, then this could have become that. But because he took everybody and put them in two separate groups that were independent, that's what makes this a 2-sample t-test. And that's what we're going to get to in part D here. Identify the significance test Scooby-Doo should use to analyze the results of his experiment and show that the conditions for this test are satisfied. So, like I said, 2-sample t-test. R is our random assignment given. So we knew it was randomly assigned. I, it's plausible that the amount of barbell curls a person can complete is independent of each other. And we have two independent groups. Okay, 29 is less than 10% of all people curling barbells. Now, N in this case are nearly normal. We have 3 potential ways of getting our nearly normal. The first one is that it would say it's approximately normal in the problem. Unfortunately, there was no mention of that. So we go to the second option, where this is when we look at our central limit theorem. So if our sample size is greater than 30, then we say it's large enough and we can proceed by the central limit theorem. We don't have that either because we had 29. So then we can look at the picture, which in our case is nice for us because it's given our picture. We have the 2. So remember, in this case, because it's 2 samples, we would need 2 pictures. But my guess is that you would be provided a picture, because they're not going to make you calculate anything for this particular year. But in this case, so now this is when we kind of fudge based off the picture and just kind of get what we want. So we said it was a slight skew to the right in this part, but it could be roughly symmetric. And that's what we're going to go with when we go to describe it. So there's no strong skewness or outlier shown in either picture of the distributions. We can assume it is approximately normal. Because remember, if you get down to the picture part, we're really just trying to take that picture and fudge it enough that we can understand why we're performing our test still. So because there's no crazy outliers, there's no skewness that's really standing out to us, we're going to go with it being approximately normal in this case, just so we can proceed. Okay. And now finally we get the p-value for Scooby-Doo's t-test is 0.107. What conclusion should Scooby-Doo make at the alpha level of 0.05? So remember, we have our blanket statement pretty much here. Since our p-value is high, in this case the high is just bigger than 0.05, we fail to reject HO, the null. We do not have evidence that a person receiving encouragement can curl more barbells than a person who is not receiving encouragement. So in this case, remember, statistically significant is below the alpha level because it's so rare that it happens. It's weird that we would have gotten it, or in this case, Scooby-Doo would have gotten it in his test, right? So to be statistically significant, we reject when it's low. So if you have a low p-value, if it's lower than your significance level, that means your data is statistically significant and we can reject. This case, the 0.107, is higher than my significance level, so we fail to reject. Okay, so we talk about that. We have the context, because again, if you could answer this question and it could have been to any other question, like anything else we've done all year with a p-value, if you just said the null is high, so we reject, or excuse me, we fail to reject, then that would not have been enough information. You have to go in and talk about what the evidence we have now. So it talks about our Scooby-Doo information in the context of the problem of encouragement. Okay. Now, so this question was broken up into 5 parts. What could also happen in this kind of question is it could maybe tie together at the end here with our type 1 and type 2 error. So maybe it would have had a part F and they ask you about that. So if that's the case, remember, a type 1 error comes from rejecting when we weren't supposed to. So if we made an error, this would have been a type 2 error because we failed to reject. So failing to reject is type 2, and rejecting when it shouldn't have been rejected is type 1. Okay, so that just could have been something that was extended onto this problem. Remember, you have a question that's going to take 25 minutes, so it's going to be broken up into parts that take up to 25 minutes. And then you have a question that's 15 minutes. So again, both of these questions are going to cover multiple parts. Just a little recap of what it could be. All right, guys. Well, thank you for watching and have a great weekend.